Dr. Chamitha de Alwis is a senior lecturer at the School of Computer Science and Technology, Faculty of Creative Arts, Technologies and Science in University of Bedfordshire. He is also a senior member of the Institute of Electrical and Electronics Engineer at SMIEEE and a fellow of the Higher Education Academy. He also offers consultants service in areas related to mobile networks and cybersecurity. Chamitha holds a Bachelor in Electronic and Telecommunication Engineering with first-class honors from the University of Moratuwa and PhD in Electronic Engineering from the University of Surrey in UK. Chamitha's researcher interests focus on cutting-edge areas such as artificial intelligence security, cybersecurity, network security, 5G, 6G technologies, and blockchain. He has successfully secured numerous competitive research grants and actively contributes to several high-impact research projects. Thank you. This now we will continue with Dr. Chamitha, please.
Hi, Paula. We had some sort of a time mishap, but hopefully that's fine now. And
Yeah.
I'll that's fine. I think, but I'll focus more on 6G security as a whole area. So I saw that the previous presentation by Anne, it also focuses on the paradigm shift between from 1G to 6G. So I'll try to sort of have minimal overlap. So well, you might ask why 6G and we already have 5G. So the obvious answers are like yes, the expansion of IoT, massive availability of small data, which is sort of like increasing, and we get a lot of self-sustaining networks, and sort of like the integration of communications, computing, control, localization, sensing. Zero energy IoT, and many advancements of communication technologies, gadget-free communication, and surprisingly, the increasing elderly population is also one fact because they will demand more and more ambient assisted living, and all other emerging technologies and applications. So I will not sort of like go through the previous mobile networks and generations because I saw the previous slides and they were covering them in detail. So if you look at 6G, from 5G, actually, we are moving towards a very different paradigm shift. So as Bart also mentioned, it's not just 5G on steroids or 5G with a boost of AI. It's actually very wide. It has a very wider scope. So this is why like we envisage peak data rates in the range of terabits per second and extremely low end-to-end delays ranging from like 0.1 milliseconds, very low processing delays, and reliability and availability in the range of 7 nines, and also extremely large connection density devices, and extremely high energy efficiency, spectral efficiency, and very high mobility, because we are also looking at catering to very new applications like space and deep sea tourism. And also we'll see a lot of new applications like UOVs, holographic telepresence. Uh, so, uh, so, so this first figure shows actually the paradigm shift between 4G and 5G towards 6G. So we can see that it's a it's a significant leap, that this is what is envisaged with 6G, and we envisage to see 6G networks by 2030. So this is the envisaged timeline to see 6G, and we will have a lot of new applications ranging from collaborative robots or cobots, UAV-based mobility, intelligent healthcare, smart grid 2.0. So if we look at all those things, what we will see is that this new paradigm, which is very different or very comprehensive or that is very distributed. So all these things will increase the attack surfaces. All these things will maybe open up new for new threats. So this is why we should be really serious, and we should really look at 6G security aspects. So this is something that many researchers, including me, are focusing on. So if you look at the paradigm shift of security towards 6G, so from analog voice, which we had from 1G, where networks were prone to physical attacks and stuff, and then came 2G, so we had sort of like authentication issues, and then with 3G, we had sort of IP traffic security issues, viruses, spyware, and with 4G, sort of like networks started to get these advanced persistent threats, DDoS attacks, malicious apps. And with 5G, now we sort of experience things like cyber warfare and sort of attacking to critical infrastructure. And we, in news, we also start to see like some critical infrastructure breaking because of cyber attacks. And with 6G, actually, this attack landscape will grow. And we can actually categorize the attacks or the security threat landscape of 6G into three main categories. So one can be pre-6G related security issues. So those are issues that are inherent to sort of like pre-6G technologies, or already sort of testing local 5G or 6G networks. So they can also relate to some security and privacy issues related to IoT that's moving towards IoE. And we can also look at the other category, which is security threats of 6G architecture. So actually, we will see a lot of new things ranging from tiny cells, um, mesh networks, multi-connectivity, sub-networks, RAN co-convergence, zero-touch networks. So these will sort of introduce some new threats. And the other area is the security threats of 6G technologies. So these technologies are the ones that sort of power 6G architecture, 6G technology, 6G services, and 6G applications. So they may range from artificial intelligence, machine learning, blockchain, quantum computing, visible light communication. So one example for security issues that might come from pre-6G technologies is we envisage network slicing also to be a key part of beyond 5G networks. So this part of our research sort of focused on finding what are the security issues related to network slicing, and we sort of explored and found that there are many areas where there are security issues related to network slicing, ranging from life cycle security of different network slices, interslice security, intraslice security, slice broker related security, SLA management, ZSM or zero touch network security, and network security related trust and privacy. So these will sort of escalate, or these will towards trickle down to beyond 5G networks, including 6G also. And if we look at the technologies that power beyond 5G communication networks or 6G communication networks, so these like AI, DLTs such as blockchain and quantum communication and terahertz and visible light communication. So those are some sort of predominant technologies that power this, or that will power 6G networks. And AI, well, this is something like a very a hot topic these days. So it's AI, yes, it has its marvels. However, it is also susceptible, sort of vulnerable to some security threats, such as model poisoning attacks, evasion attacks, uh, machine learning related API based attacks, infrastructure attacks, or compromising of AI frameworks. And if you look at DLTs such as blockchain, we can see like Eclipse attacks, or sort of like 51% attacks, or end user vulnerabilities, software vulnerabilities. And when we look at quantum communication, so this a completely a new area that is sort of that scientists are working very hard to realize. Still, like there are a lot of vulnerabilities there, or like areas which are still not understood, such as probably quantum entanglement, how it works, and sort of how to do multicast and broadcast with quantum computing. Um, with that, like there can be quantum cloning attacks, quantum collision attacks, and with terahertz communication, we can have access control attacks, eavesdropping, same with VLC, and jamming with VLC. So, so you can see that there are still areas that we need to work on. However, these are actively these are active research areas. So there are many research work on these areas. Oh, there's still there are a lot of opportunities to work in these areas. And if you look at 6G, we also sort of understand 6G to have a lot of AI and intelligence built in. So, so if you look at the 6G architecture, well, there are different ways of presenting 6G architecture. So this is one way of looking at it, such as we can look at the intelligent sensing layer, which will sort of be connected to all these devices and IoT devices and so on and so forth. And then it will be connected to the edge layer, which will have data centers and edge servers, and then it will connect to the intelligent control layer that will have the centralized crowd, and then it can be connected to different applications. So all these layers uh, actually also have also come with some new security threats. So if you look at the intelligent sensing layer, we can see that there can be cryptographic systems that are not strong enough, maybe with quantum computing, or maybe there can be rogues or compromised IoT devices, data theft, eavesdropping. And if you look at the intelligent edge layer, there can be sort of like physical security threats, DDoS attacks, man-in-the-middle attacks, and then there can be attacks on the edge-based different microservices there, and then there can be attacks on different machine learning models. And if you look at the intelligent control layer, we can see that there can be attacks on software-defined networking controllers, interfaces, virtual machines, hypervisors, and information theft or DOS attacks. And even if you look at the application layer, still there are data privacy issues. Maybe like there's absence of machine ethics when it comes to automation, and there can still be 51% attacks on blockchain, because we expect that the blockchain will be a key enabler or key component of many 6G applications. And if you look at 6G application requirements, so many applications that we discussed before, ranging from connected autonomous vehicles, smart grid, Industry 5.0, intelligent healthcare, digital twin. So all these things, if you look at these requirements, you can see that security is a paramount. So say, for instance, if you look at intelligent healthcare, you can see that we really need ethical AI security, and then we need high privacy, scalable IoT data security. And if you look at digital twins, still we have like IoT data security, AI security, secure communication. So if you look at this, we can see that one of the key requirements or key demands of this 6G application is actually having a secure environment that will ensure security and privacy. So if we sort of go into detail, uh, we can see that these applications, these 6G applications actually have very diverse security requirements. And if you look at their security and implantation challenges, that is also quite diverse. Say, for instance, if you look at UAV-based mobility, that will have sort of security requirements, like the critical ones might be extremely low latency, extreme scalability, zero touch security, and security via the edge. However, if you look at something like Industry 5.0, that has different security requirements. So maybe that has, in addition to the ones that we discussed before, it might have need proactive security. So maybe zero touch security to operate like autonomous in an autonomous fashion. And the challenges are also quite diverse. Say, for instance, like energy efficiency is a big challenge for UAV based mobility. However, like if you look at something like smart grid 2.0, so it has different challenges like physical tampering, terrorist attacks, because these sort of deal with so tampering a smart grid 2.0 network might sort of impact the energy grid of a whole country. So what can we do to resolve these issues? So this is what we really need to work on and focus on. So there are different solutions that scientists are working on, researchers are working on. So I will sort of focus on some of them, which I think are prominent. And so one such thing is actually like um, so yes, before going to that, uh, uh, when it comes to AI security, so we actually look at AI security in sort of two different ways, because like we need to secure AI, and then we can use AI for security. Say for instance, like if we look at different autonomous systems, we can use federated learning, deep learning, and privacy preserving machine learning. So these ways we can actually use AI for security. And then if we consider like security for AI, we can see that this way we can actually consider like ethics, and we can build resilient models, and we can actually build trustworthy models. And actually, like AI is sort of so that's one of the prominent solutions that we are looking at in sort of enabling as one of the potential solutions for 6G security. So considering the nature of AI, actually, like it is also considered as a double-edged sword. So it can be used for different purposes. Say, for instance, AI in 6G can be an enabler of security, uh, enabler of technological enabler. It can also act as a defender of 6G networks. But not only that, it can actually sort of be an offender, so it can also make it a target, right? So so if you look at how adversaries act, we can see that they can use AI models to sort of like steal data. They can detect vulnerabilities, they can automate their tasks, they can launch different attacks using uh, for AI models. They can do some things like poisoning data. They can attack to this model poisoning in different ways, in the learning phase, inference phase. So it can AI can be looked as a threat. And on the other hand, AI is actually an enabler, because it sort of enables a lot of 6G related tasks, such as automating different network service and management and stuff. However, if you look at in the security aspects, we can see that it also helps to sort of have security in different parts of 6G, maybe like for intelligent authentication, authorization, or maybe for anomaly detection with AI. So actually this AI and 6G landscape is a very sort of broad one. So it's there are many knowns, there are many unknowns. So that's why it's a very hot topic, a very hot research topic at the moment. So there are many people who are working in AI and 6G security. And another sort of interesting area in AI and 6G security is explainable AI, because when people use AI for different tasks, like they start to question, okay, so how do they make the decisions? The decisions that they make, are they sort of ethical? Like, what's the decision making process? Can we sort of look at the process and see if it follows the essential steps? Or can we defend this in the in a court? So in that, in such a scenario, we need to know, we need to break down the basic steps of how these things are working. So that's why explainable AI is and also like explainable AI for 6G is also becoming another hot topic, another hot research topic. So so they sort of start to uh, uh, decipher these AI models to see like why, what's happening, where, and how things are happening, and what are the technologies being used inside. Like so this is also another interesting area when it comes to 6G security. And actually, we can apply this XAI into 6G security in across the 6G networks, like starting from where it's sort of starting from devices, IoT devices, or any other device that people use to get connected to 6G networks. And also we can use this XAI in the core or the network edge, and we can also use this XAI in different services and also applications. So this will allow uh, researchers and also like operators and also governments to sort of understand how these networks, how these technologies work, to decipher them, to make them more efficient, to they make them more secure, and ensure that they sort of align with any regulations or any other policies of different governments or countries or operators. The other technology that is really interesting when it comes to 6G security is blockchain. So blockchain has a lot of advantages, and blockchain actually is used for many parts or many aspects in 6G. However, still, if you look at this diagram, you can see that there are a lot of attacks that can happen to blockchainized 6G platforms, starting from like poisoning attacks, or like sort of looking at different sort of Sybil attacks or like spoofing attacks. So these kind of things actually like make uh, using blockchain in 6G also a bit challenging. However, like this is also another research area. So you can see that most of the technologies that we are using for 6G security, so still this is a growing area. So like people are, or researchers are still exploring, okay, we can use this technology, that's fine. It has proven itself as a uh, 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 very prominent technology, very capable technology. However, still there are some remaining challenges. So actually, this is why these areas are very good for researchers to sort of explore and then resolve these issues. And actually, blockchain has a role in enhancing 6G security in multiple aspects. So if you look at zero energy IoT, that can sort of increase the efficiency of these kind of activities while securing it. So you can see that it's throughout 6G networks. So this is why like blockchain and 6G security is a very key research area. And another interesting area is quantum computing with 6G security. So this is uh, this is a very interesting topic. We actually recently also published a survey article on this, which might appear online soon. So here, actually, there are many areas that such as like maybe post-quantum safe cryptography, and what kind of quantum-based attacks can happen, and quantum key distribution, how we can sort of implement these things, and how can we build quantum-resistant network hardware, and along with that, how can we sort of do machine learning in a quantum computing environment to make it more efficient and safe, and how can we sort of do quantum assisted communication. So all these are the aspects that are currently being researched on and developed on towards attempting to develop a quantum safe 6G communication platform. So like some researchers believe that there are still a lot to happen to have quantum computing by 2030, and to make it a key technology by 2030. However, like even with 5G, we saw that many key technologies sort of started to appear uh, maybe like after 4 or 5 years of 5G being launched. So some scientists believe that that's the same case with quantum computing. However, only time will tell. So like there are many research work going on in this area. Um, and even when it comes to physical layer security, well, we will have a lot of new challenges, because uh, currently researchers are looking at many new things, like such as intelligent surfaces, how or like some people call them reconfigurable intelligent surfaces, how they will work. So these are actually like very hot research topics. So people are working on realizing sort of efficient and sustainable ways of implementing intelligent surfaces. And using visible light communication is another very interesting area. So that some believe that we can replace Wi-Fi and those kind of technologies where you sort of connect different devices, maybe like maybe inside stores you can have some devices that might connect with the Wi-Fi or something like that. However, like when it comes to visible light communication, we see that tampering visible light communication is very easy. Even a small torch can do that. So, what are the measures against that? So, these are also some areas that people try to research on, and some completely new areas such as like uh, molecular communication. So, these are very hot topics, and these these areas try to sort of merge the developments of biological sciences with communication technologies. And actually, like that's also a very new area to me, even how this molecular communication can happen, and how the security of that molecular communication will be, because that requires a lot of knowledge that we should bring from biological sciences towards these areas, and maybe like physics. So if you look at 6G security, so considering all the aspects that we discussed, we can actually sort of derive some KPIs that we need to have a strong 6G security. So like maybe we can look at protection level. So like different applications will need different protection levels based on the sensitivity, the time to respond. So that can be sort of like if something happens, how much time or what's the time scale that we need to sort of look at in responding to that, the coverage of the security aspects, and how what's the autonomicity level, and then the robustness of this AI, and security AI model convergence time, security function chain round trip time, and the cost to deploy. So these are some of the KPIs that's being identified when looking at 6G security. So different applications based on their requirements may have different KPI requirements for these measures. And actually, that's the end. I think I try to finish within my 30 minutes. Paula?
See, tell me, we have some questions.
Yes, that's fine. That's fine.
Okay. Where is from this guy? Yeah. Thank you, Dr. Chamitha. Here we have some questions in the chat and also internally. How do you envision the integration of blockchain enhancing security within the IoT ecosystem, especially in the context of the next generation network like 6G?
Yes. So, well, it's this is also a really interesting research area. So, at the moment, even like if you look at how people mine Bitcoin and use Bitcoin, we can see that sort of there are different mining nodes and there are different other nodes that use these kind of services. So, I think the same. So, as per my knowledge, or as per the knowledge that we currently have, I think like the same sort of structure will evolve. So there'll be a lot of devices that will be using this kind of blockchainized systems. However, still there can be a lot of mining nodes in the edge, and they will do the blockchain mining. They'll do the consensus and all those kind of behind the scenes activities. And I think it will make a lot of these IoT devices operate in a large network in a very trustworthy manner, because at the moment the problem is sometimes like okay, how can we make this trustworthy, because there are different devices operating in different ways. How can we ensure the security? So like these are areas about blockchainized IoT and blockchainized 6G network try to address. I hope I answered the question.
Thank you. Someone is having some questions because here I have one. more internally. I don't know, someone. Yeah. What are the main cybersecurity challenges that IoT device will face as they become more embedded in critical infrastructure supported by 5G and 6G networks?
Can you repeat the question, please?
Yeah. What are the main cybersecurity challenges that IoT devices will face as they become more embedded embebido in critical infrastructure supported by 5G and 6G networks?
Okay. So, well, the thing with IoT is, I think, like the same characteristics that we observe at the moment, because they are devices that will need a very sort of like uh, they'll need to preserve their power. So they have limited battery capacity, and then they sort of have very less sort of processing capabilities. So I think these will evolve, but with time we envisage that edge computing will sort of empower IoT devices to take more better decisions, to have more computational power, but still the same challenges that we already experience will sort of evolve. However, like when it comes to critical infrastructure, so one of the research that we focused on is actually smart grids. So smart grid 2.0. So we sort of envisage that. Because at the moment we see that there's a lot of initiatives to implant this uh, s- renewable energy, such as maybe solar power and stuff for different houses. So then each of these things also integrate a lot of IoT devices, and they become a part of a very large infrastructure that powers maybe countries. So in those things, actually, like it becomes more so maybe a country can become more vulnerable, because this is sort of like connecting the power grid with the IoT network. So the existing challenges will sort of evolve. However, on the other hand, there'll be a lot of security or AI based security starting from the edge. So that is what we envisage. And also we sort of are currently looking at many new physical layer security aspects that sort of will empower these IoT devices even with less processing capability to have better security. So all these are very state of the art research themes, and hopefully by the time that we see 6G, we will see that these technologies being realized.
This is very interesting, and if I may just add on top of this, this reminds me of the general problem we had with the IoT devices. So if you begin with the invention of the IoT, which is let's say some years back, we started to see the problems of data. So we started to produce a lot of data. And then we had the cloud, so we were sending everything to the cloud, and we realized that we need to do some intermediate aggregation of data and some data processing. So that's why we introduced, let's say, fog computing. Right, and now people even talk about mist computing, and essentially mid layers between the edge devices and the cloud. With security, we also have a similar problem, because not only we have to collect all the data from those devices. In the meantime, we also have to collect additional data like telemetry, battery, authentication data that needs to be processed. So this is why, and this is coming back to my previous also comment with Anne, we need this lightweight mechanism. So at the moment, we send aggregated data to, let's say, intrusion detection system, and we try to figure out if maybe one of our edge devices was attacked or not. We need to do this intermediate processing, but it costs. It costs a lot in terms of energy and the processing power. So that's why there are many researchers that are looking into this lightweight security enhancement of this edge devices first. Then they try to secure the fog, and then eventually, before even it gets into, let's say, some kind of intrusion detection systems, we need to do a lot of pre-processing in terms of the security before, but the cost is enormous, right? If you have a device that can last a year, and it produces on one battery, and it produces some data every couple of minutes or maybe every couple of seconds, and then you add a security function on top of this that isn't really optimized, you may reduce the battery power to something like few days, or even few hours, if you need to run some kind of models on this. So this is a big research problem, and again, I invite people to look into this because lightweight security solutions are needed. So yeah, just on top of what Chamitha said, I think this is quite interesting problem.
And what to add to that, actually, like with IoT devices, we start to see the demand for small data. So like we are quite familiar with big data, where we use data that we collected for a very long time probably, and then to see the statistical patterns. However, when it comes to small data, sort of we try to collect data that is relevant for the time, so that is very recent maybe. So and then to make decisions on that. So for that we need to collect this data, process this data. Say one example is maybe like the operation of a machine. So we need to collect this data from different sensors across the machine, and to see like if there's a if we envisage a failure, how it will happen, and to collect this data. So in these kind of things, collecting this data and sort of coordinating different IoT devices, and connecting them. So this is a very big challenge, and then it also opens up new security challenges, because there's very less time to verify this data, to sort of check this data. There can be some model poisoning attacks. So actually, like a lightweight and powerful security sort of algorithms and technologies, it's a paramount.
Yes, and we realized this during the deployment of 5G. And then obviously everything that you said requires ultra low latency. And the latency that we had with 5G was not so bad, but for this almost real-time applications, when instant feedback is needed and instant data is required, then we need ultra low latency. So this is what we try to also do with 6G. But of course, the management of all of this is not straightforward. That's why we still don't have an official design and architecture of 6G. This is what projects like HexaX2 and similar projects are trying to do. So I think there are a lot of people that put their efforts into the defining what 6G is based on. This is one of the requirements we just gave: ultra low latency, instantaneous data, near real time communication. So yeah, definitely a lot of opportunities there as well, and challenges, I guess, that come with
Yeah.
it.
Okay, thank you very much, Chamitha